Math 3, practice 3.1.4, evaluating trig functions. Okay, so the first four, we're given a specific point. We want to find essentially their reference angle, okay, the trig ratio for it, kind of. So, let's think of it kind of like that unit circle idea. Okay, so the point is negative 2, 7. So I'd go back 2, down 7, right? Something like that, negative 2, 7. So starting from my initial part, we'd go down there. So that would be my angle right there. Okay. Now this also forms a right triangle. Okay, and that's going to be the key to it. This side right here is negative 2 because that's the x value. This side right here is 7 because that's the y value. So we need our hypotenuse because cosine, thinking of SOHCAHTOA, almost combine those two. Cosine is the adjacent over the hypotenuse. Okay. So it wants to know what's the adjacent and what's the hypotenuse. So my angle would be this one right here. Okay, that one right there. And so the adjacent would be negative 2. Okay. And the hypotenuse is what we need to figure out. Because it's a right triangle, I can use the Pythagorean Theorem. So negative 2 squared plus 7 squared equals my hypotenuse squared. So negative 2 squared is positive 4. 7 squared is 49. So 53 equals hypotenuse squared. Take the square root. So I get the square root of 53. Now it says it wants an exact, so I don't turn that into a decimal. Okay, so that's simply right here, square root of 53. So cosine is adjacent over hypotenuse, so it would be negative 2 over square root of 53. Now there's a problem with that. We don't like having a square root on the bottom, so I'm going to have to adjust that to get it to work. So basically what that turns into is I just multiply by the square root of 53 over the square root of 53. So then I get negative 2 square roots of 53 over square root of 53 times the square root of 53 is just 53. And that's all I need to do on that one. Okay? So basically, you don't really need to draw that unit circle, but that was just to give you an idea. But we're going to have a right triangle here, right? Well, it's kind of nice to have that unit circle idea, or at least the coordinate to give you an idea. So cotangent of theta with 4 and negative 5. So 4, negative 5, be right there, wouldn't it? Okay, or this side. So that would be 4, that would be negative 5. Okay, now with cotangent, we actually don't need the hypotenuse, right? Because tangent is opposite over adjacent. The cotangent is just that reciprocal, so the adjacent over the opposite. So if our angle's right here, the adjacent would be 4, the opposite would be negative 5. So negative 4 over 5, and we're done with that one. That one wasn't bad, was it? Okay, now the next one. So the secant, remember secant is opposite of cosine, so the secant would be not adjacent over hypotenuse, it would be the hypotenuse over the adjacent. Okay? So we draw our unit circle and it's 0, negative 1. 0, negative 1 would actually be down here, wouldn't it? Okay? So our angle would go down there. Okay? So that's a 90-degree angle. Okay? Now we run into a problem here because usually the adjacent is the x value. My x value is 0, so whatever the fraction is going to be, it's going to have 0 on the bottom, which we cannot have, so we call this undefined. That one just doesn't have an answer, it's undefined. Suppose it does have an answer. The answer is it's undefined. Okay. Okay, number 4. So we go -12, -5. So our angle would look something like that. Okay, so our triangle, -12, -5. Now it's sine. Sine is opposite over hypotenuse, so -5 squared plus -12 squared equals hypotenuse squared. So that'd be positive 25, positive 144. We get 169. Take the square root of that, and we get 13. Square root of 169 is 13. So it's this angle, the opposite, -5. So -5 over 13 is our answer for number 4. Alright, so there's our first ones. Now the next 3, 5 through 7. Determine the specified trigonometric ratio for each special angle. Give exact answers. So it's kind of the same idea, just basing it off the angles. Okay, so we've got the unit circle here. Need to split up each half into 6. So 1, 2, 3, 4, 5, 6. Okay, and we have 7 of them. So we start here and we go 1, 2, 3, 4, 5, 6, 7. So there's our angle right there. Okay. So we've got that triangle right there, right, with that smaller angle. So what I need to do is figure out what that smaller angle would be. Okay. So if I think about it, pi would be 6 over 6, wouldn't it? So we have 7, so that would be 1 extra pi over 6. It's like each of these are pi over 6, pi over 6, pi over 6. And this last one is pi over 6, so that tells me what the angle is. Okay. Now, this goes back to those special right triangles. Okay. There's certain angles that have a certain thing going on, pattern, I guess I should say. So we have 45, 45, 90 triangles. We have 30, 60, 90 triangles. Okay? The way it works is that with 45, 45, whatever the legs are, they're the same, and the hypotenuse is the leg times the square root of 2. For the 30, 60, 90, the smaller side, remember, everything's based off that. Whatever side that is, the hypotenuse is twice as big as that. The longer side is that length times the square root of 3. Okay, well, what's pi over 6? Well, if you're not sure, times it by 180 over pi. Those cancel. 180 divided by 6 is going to give me 30. So my reference angle here is 30. Okay, and we're going for the sine. So sine is opposite over hypotenuse. Okay, so the opposite over the hypotenuse means the x's cancel and we have 1 over 2. So the sine of pi over 6 is 1 over 2. So the sine of 7 pi over 6 is 1 over 2. Now the thing we have to remember is because it's in this quadrant down here, my x value, okay, they're both going to be negative, right? Because this would be a negative number, this would be a negative number. I took the opposite, so it would make it a negative 1/2. So you kind of have to pay attention to that, those positive and negatives. Because it wasn't just pi 6th. If it was just pi 6th, it would be positive 1/2. But because it was 7 pi over 6, I changed its location and also changed its sign to negative. Okay, tangent of 3 pi over 4. So, same idea. Okay, if I split it into fourths, but I've only got 3 of them. 1, 2, 3. So my angle goes up like this. Okay. So, what's this reference angle? That's kind of what we're looking for. Okay, well, pi would be 4 over 4. So if I go 4 pi over 4 minus 3 pi over 4, I'm going to get just pi over 4. So I want the tangent of pi over 4. Well, what is pi over 4? If you didn't know, times it by 180 over pi. Pi's cancel. 180 divided by 4 would actually give us 45 degrees. Okay, because 45 plus 45 is 90, so 4 of them makes 180. So that is really 45 degrees. Okay, so 45, 45, 90 doesn't matter our reference, but tangent is opposite over adjacent. So it's x over x. So it would be 1. Okay, now the problem is, because of our angle, if I were to make the triangle right here, this would be a negative x, that would be a positive x. So it would actually end up being negative 1, because it's to the left and up. So negative 1. Or negative 1 over 1, same thing. Alright? Now number 7. Okay. We've got pi thirds. So we cut it into thirds, so I'm going to eliminate this actually. So 1, 2, 3. And it's just pi over 3. So that means it's 1. Okay, so this one's going to be a little bit easier. So it's looking like that. Okay, now pi over 3, if we times that by 180 over pi, we end up with a degree of 60. Okay, so 60 is this reference angle. Now we're doing cosecant. Cosecant is the opposite of sine. Sine is opposite over hypotenuse. So we've got hypotenuse over opposite. Well, the opposite of 60 is the side length times the square root of 3. The hypotenuse is 2x. The x's cancel, so I get 2 over square root of 3. Problem is we can't have that on the bottom, so we times by the square root of 3 over the square root of 3. That becomes 3. That becomes 2 times the square root of 3. Okay? They're both positive because they're both in the upper right. So it's 2 square roots of 3 over 3 for the cosecant. And those are our exact answers. Okay? And you'll see those numbers popping up a lot when we deal with these special angles. Alright, let's take a look at the last 3 now. It says for each angle is described by one of its trig ratios and the quadrant in which its terminal side is located. Find the requested trigonometric ratio for the angle. Okay, so it's kind of the same idea. It's the difference is they're just telling us a few pieces of information in which quadrant. So the tangent is 2 over 3. Tangent, remember, is opposite over adjacent. Apparently I'm just going to write a bunch of these. Okay, now if we make a triangle, this would be our reference angle. The opposite would be the top, so 2. So that's going to be 2. The bottom's going to be 3. Now it tells us it's in quadrant 3. So quadrant 1, 2, 3, and 4. So that means my angle is going to be something like this. Okay? So this opposite side is actually going to be negative 2, and the adjacent side would be negative 3. So it's like I just had to flip my triangle around, like to the third quadrant. Okay? Now I actually want to find the cosine. Okay? Cosine, remember, is the adjacent over the hypotenuse. So I need to find that hypotenuse. So using Pythagorean Theorem, I go 2 squared, or negative 2 squared, I guess, plus negative 3 squared equals my hypotenuse squared. So that would be positive 4 plus positive 9 equals hypotenuse squared. So I get 13 equals hypotenuse squared. Take the square root. So the hypotenuse is the square root of 13. Okay? So the adjacent side would be, okay, according to our angle, negative 3, so it would be negative 3 over the square root of 13. But we can't have the square root of 13, so we times by the square root of 13. So I get negative 3 square roots of 13 over 13. Can't simplify it, so there's our answer. Okay, so now we're going to do the same thing with 9 and 10. Okay. So 9 wants us in quadrant 4, so this quadrant. Okay, we're given the sign. The sign tells me the opposite side, so if I draw my triangle here, so the opposite side would be, because the reference angle is always in here in the center basically, would be -3. Okay, the hypotenuse would be 5. To find the secant, okay, the secant's opposite of cosine, so it's going to be hypotenuse over adjacent. Well, we already know the hypotenuse. The hypotenuse is going to be 5. So what's the adjacent side going to be? Well, to figure that out, we go the adjacent side squared plus -3 squared equals 5 squared, the hypotenuse. So we get 25 there, we get 9 here. Subtract 9 from both sides. We get a squared equals 16. Take the square root, and a equals 4. So the adjacent side is 4, which means the bottom is 4, so my answer is 5/4. That's the secant. Okay. Now number 10, once in quadrant 2, so this quadrant right here, okay, gives us the cosine is -1/2. Cosine is the adjacent over the hypotenuse. So we draw our triangle here. The adjacent would be -1. Hypotenuse would be 2. Now cotangent is the opposite of tangent. Tangent opposite over adjacent. So this is adjacent over opposite is cotangent. So the adjacent would be -1. The opposite is what we've got to figure out. Okay. So once again, using the Pythagorean Theorem, -1 squared, we're looking for the opposite side squared, equals our hypotenuse squared. So 1 plus the opposite side squared equals 4. That's not a 0, using it for the opposite, so we get 4 minus 1 is 3, square root of 3. Okay, so our opposite side is the square root of 3, which we can't have, so we simplify. That gives us negative square root of 3/3. And there's that one. Kind of crazy, but there we go.